Hello everyone, my name is Shivanandra from EC department. I am doing an internship in Emertxe with embedded system course. We as a team done a project on microwave oven. Let me introduce my teammates. First is SV Subbareddy, next Sai Prudvi, and D Mohammad Shafi. My friend will continue the explanation.
Now coming to the oral explanation of our internship and project. I would like to give I would like to tell the main aim of the project we done that the microwave oven will operate in three different modes as follows. Mode 1 is micro mode. Secondly, grill mode, and the third one is convention mode using PIC 16F877A microcontroller. Now coming to the goals of internship, under the duration of this internship, we have gained some basic knowledge on programming C language, including data types, keywords, conditional loops, data structures, etc., and briefly about embedded systems. And also embedded programming about CLCD means characteristics liquid crystal display, and under banner of internship project, and we have learned practical and embedded programming knowledge. Now discuss about microprocessor and microcontroller. A microprocessor is a processor where the memory and the input output component are connected externally, whereas microcontroller is controlling device wherein the memory and the input output component are present internally. In microcontroller, CPU, RAM, ROM, input output and timer are all on a single chip, but in the case of microprocessor, CPU is standalone, RAM, ROM, input output and timer are separate. And coming to microcontroller, fixed amount of on-chip ROM, RAM, input output ports. And coming to the microprocessor, designer can decide on the amount of RAM, ROM and input output ports. Controller is used for only single purpose, and microprocessor is a general purpose micro microcontroller is a highly bit addressable, and microprocessor is expensive. Now let us see about block diagram of PIC microcontroller. PIC microcontroller is mainly based on this architecture. Its memory architecture follows the Harvard pattern of separate memories for program and data with separate bases. PIC microcontroller is divided into many parts. Let us see about my memory structure. The memory structure consists of two memories, program memory and data memory. Program memory is a 64K memory place. It is used to store 13-bit instructions or the program code. And coming to the data memory consists of 68 bytes of RAM and 256 bytes of EEPROM. The 368 bytes of RAM consist of multiple banks. Each bank consists of general purpose registers and special function registers. And now coming to the input output ports, and we have five ports such as port A, port B, port C, port D and port E, and these all ports are of the port A is a 16-bit port, port B is a 8-bit port, port C is a 8-bit port, port D is also an 8-bit port, but port E is a 3-bit port. And coming to the timers, PIC microcontroller consists of three timers, of which the timer 0 and timer 2 are 8-bit timers, and the timer 1 is a 16-bit timer, which can also be used as a counter. And we have also a analog to digital converter. The PIC microcontroller consists of 8 channels, 10-bit analog to digital converter. The operation of the analog to digital converter is controlled by these special function registers EDCON 1. And coming to the oscillators, oscillators are used for timing generation. PIC microcontroller consists of external oscillators like crystal or RC oscillators. And coming to the CCP module works on follows three modes. First one is capture mode. This mode captures the time of arrival of a signal, or in other words, captures the value of timer 1 when the CCP pin goes high. Second one, compare mode. It acts as an analog comparator that generates an output when the timer 1 value reaches certain reference value. And the last mode, PWM mode. It provides pulse width modulated output with a 10-bit resolution and programmable duty cycle. Okay, now let's see the PIC 16F 877A simulation board, and we are going to work on this board. And let's study about embedded systems. What is embedded systems? Embedded system is defined as the combination of hardware and software where embedded the firmware into the hardware to do specific one or few highly focused jobs, often with real-time constants. Example: smartphone, washing machine, ATM, etc. The advantages of the embedded systems as it reduces the physical efforts and stress, it provides security in comfortability, and it reduces cost. Example: ATM cards, mobiles, washing machine, airbags, CC cameras, etc. And now compare the embedded systems with the general purpose registers computer system. The general purpose computing system consists of hardware and general purpose OS, whereas embedded system is specialized hardware and real-time OS. And general purpose computing system applications are altered by an user by GPC system, and in this computing system response is not time critical and performance is the key deciding factor for GPC systems. And now coming to the embedded systems, response is a time critical. Example: airbags, anti-lock braking systems, and performance and cost, size, speed are key factors of embedded systems. And now coming to the let's study about the architecture of embedded system. The main heart of the embedded system is the system core, and everything is interlinked with it. Then the memory, for coming to the memory, it contains mainly two types of memories. One is temporary memory and permanent memory, and there are other memories: flash memory, EEPROM, etc. And system core accepts input ports from the input, and it produces the output from the output ports. And other devices which are connected are additional hardwares, communication interfaces, etc. And now my teammate Kasib Srinivas will continue the explanation of the PPT. Thank you.
Here I will give you the overview of the project. First of all, we will see development of code and tools used and implementation. Now first of all we will see development of code. Now I will explain how to build the code power of development of code. Power of screen used to power on the microcontroller. Menu display screen to display modes, and time display screen used to display selected time. They are start or resume, pause, stop used to interrupt the running process, clear screen used to clear each mode, and set time and set temperature used to set time and temperature based on need. Now I will explain how to tools we have used to compute this project, and they are MP Lab Excite for coding and PixSimLab for simulation purpose, and CLCD is used to display working of micro oven, and matrix keypad used for giving input to microcontroller, and fan is used to detect where the oven is running or not, and buzzer is used for the identification and of ending of running process of micro oven. These are the tools. Coming to implementation process, we have three modes as follows. First mode micro mode, and second one grill mode, and third one convention mode. First mode is micro mode, is used for heating of heating the food items. This mode is used. In this mode it displays four options: micro, grill, convection, and start. After click on key 1, this mode enables. We have to set time on requirement to start micro mode operation, and fan rotating means micro mode is working. Now second mode is grill mode, use it for frying of food items. So after selecting the key 2, this mode is enables. It shows like this. It will ask the time. After setting time, we can observe the working process of the grill mode. It shows start or resume, pause, set, stop options. If we select the pause, it interrupts the running process by click on keys. If we want to again heating, we click on key 4, that is start or else. If we want to stop the process, by clicking on key 6. Coming to third mode is convention mode. By selecting the key 3, this mode is enabled. It is used for deep frying of food items. This mode is different from other two modes. Here we have to set the temperature for pre preheating purpose. It will start the time from 180 degrees. Now my teammate will continue the presentation. He will show practical implementation of micro oven.
In Pixim Lab, we can see this is the main function. This is main function and main file, and this is header file. In header file, we define some various functions, that is power on screen, menu display screen, micro mode. These are the modes in micro oven: micro mode, grill mode, convection mode, start mode, time display. Now we can see main function. In this we can see um, this is called time display screen. Use it to display the time. Now this is clear screen function. Clear screen function we already defined, used to erase the previous data. Here is the power on screen to start the working of microwave oven. Here menu display screen. It is used to display of working modes of a microwave oven, micro, grill, convection. These are the modes. Now set temperature function is here. Set temperature function. It is only used in convection mode. You can see. Here is the set time function. Set time function is used for all modes, micro, grill, and convection.
it is used to set the time as we required. Now we see the basic simulation diagram of Pixim Lab simulation process. So we can see here is powering on micro oven. There are the three modes, which is one micro, grill, and convection. If you want to in you if you want to operate in micro mode, we select one on my matrix keypad. Now we can set the time as we required. Now I select to 25. Now here star is used for clear the time, and entries hash is used for to start the process. Now I press hash, so we can observe that the fan is rotating for the time of 25 seconds. We can start or resume in case any interrupts are there, or we can pause, or we can stop the complete process by using here. Now fan rotating is stopped when I press 5, and timer also stopped. Now I press 4, again fan is rotating, and the time is up now. Now we can see in different mode of that is grill. We can select in matrix keypad, that is 2. Here also we can set time for 35 seconds. Here also same keys. Star is the clear for clear the times, and entries to start the process. Hash is to start the process. Now I am again, we can see timer is running and fan is rotating. We can observe that. We can pause, fan is fan stop, and we can resume, and timer also stop, and we can resume by clicking on 4 on matrix keypad, and again fan is rotating. We can we observe that if you want to stop this process, we can click on the 6 also, but we can wait. Let's see. 5, 4, 3, 2, 1. Yes, the second mode is also completed, time up. Now we will see the convection mode, that is 3. By clicking on 3 we can activate that. In convection mode we need to set the temperature for preheating. We can set some temperature levels. You can see, wait for it. Wait, please. Shall I confused? Confused now. You can set the temperature as 2, 4. Now I press on hash. Now 180 seconds is default time, as we already predefined it. We have to wait that 180 seconds. We can see this board in that time. Here it is a matrix keypad. These are display boards, four display boards, 7 segment display boards. You can observe these are relays, relay 1, relay 2. This is heater, this is cooler. Mm, these are interrupt pins. This is buzzer, and these are analog pins, as you see P1, A and 0 analog pins, A and 1. This is called E square prom, electrically arranged program, readable, read-only memory. You can see, port. We know in PIC 16 877A, PIC 16F 877A, we observe the 5 ports: port A, port B, port C, port D, port E. We can see port A and E is combined, and here is port B, and here is port C, here is port D, and here is also we can use USB connection also. We can observe these are LEDs. These are LEDs. Port D, port B. These are, this is real-time clock, RTC. You can see we, the time is running out. We can see RS 485. RS means recommended standard. We can use serial input pins, and we also see here reset button. When we press reset button, the whole process is in reset condition. It means uh, that running process will be collapsed. We know very well about reset button in our phones also. Now here is a load and run. We want to load or run, and here is the buzzer. We can observe that, and here is 20 seconds. This is briefly about Pixim Lab 16 cross 4. 5, 4, 3, 2, 1. That's it. Now we can set 6 seconds. Again fan will be rotating. Now convection mode is operated. We all observe. Now we already see micro mode and grill mode. Now convection mode. All modes are completed in micro oven using Pixim Lab. Now the final conclusion is overall we observed working of different modes in microwave oven using PIC 16 F877A microcontroller in Pixim Lab. Now by this Emertxe internship, we learnt about the embedded C programming and about the microcontrollers a lot. Now we conclude that we learned the different modes of micro oven. Thank you, thank you so much. Thank you for your guidance.